everything you wanted to know about the learning curve. All right, you've done a task and they've asked you to do it again. Typically, you're going to do it faster. We would probably have already made, if we wouldn't, but you've done something and you baked an omelet. You fixed a car. You changed you adjusted the brakes. You added Freon or whatever. You added air to the tire. First time you did it, a little slow. You hadn't done it before. A little bit slower. You've had to figure out how to open your car hood and get in, and then you charge the battery or whatever you did. The second time you do it, you're going to do it faster, and there'll be a certain percentage. If you did that over and over again, you would get faster at it. So on a learning curve, you've got the first time it takes you to do it, and the amount of improvement decreases the more times you do it. And every time you double the time, that's typically what the learning curve is looking at. It's a prediction tool when you look at doing something. It's a performance with people tend to go to a certain point, faster and faster. It doesn't go to infinity. You're not going to do things this fast. But if you, I cook shrimp and then peel them, I can do them in a third the time my wife can. She thinks she's supposed to shred the shrimp at the same time. So it's, when you take the shell off, you get good at it after you've done it a while. So repetition and practice mean a lot. And a percentage of time between the first time and the time you double it the second time, that percentage may be, it takes you 90% of the time to do it the second time. Between the second time and the fourth time you do it, might be 90% of the time between the second time and the fourth time. So if you looked at it mathematically, what it looks like is this. Oh, time to perform the first unit. Now, so when you double it, when you've done it twice as much from the time before, that'll give you B. So if I looked at the formula, oh my gosh, people look at this and go, huh, easy stuff. Easy. But I'm going to show you a graph, and it'll make it a lot easier in your head. You go, oh, well, why didn't you say that in the first place? Well, this is, if you want to do the math, you can just walk through these. It's very simple. But let's look at this math. There you go. It's not going to go to no time. You're going to reach a point where there's a plateau. It's not going to get much faster. Learning curve percentage of 85%. So let's say it took 9.6 minutes the first time, right? And 8.16 minutes when I've doubled the number I've done. Now I've done 2 of them. Well, I could just multiply 0.85 times 9.6. Oh my gosh, that's pretty easy. Might be, I've got 10 minutes here, and I say I've got a 90% learning curve, and this was one time. Second time I did it, 90% of that is what? 9 minutes? Okay. That makes sense. And the fourth time I did it, what's 90% of that? Oh, 8.1 minutes. See? And the 8th time I did it is 90% times 8.1. And then that's the easiest way to do it. You can do that in your head. Now, if you're doing 10,000, the thing to remember in all this is when you do the first time, you are concentrating and doing 100% of the time. You're doing 100% of your concentration you're doing right there. You're not going to the bathroom. Your time there. Click. I started, worked on it, I did it for 9.6 minutes. Is that what you do at work? You know what you do at work? Let's say this is efficiency. And this is 100% efficient. This is 50%. 0%. Okay. This is a government politician. Okay. And here are hours on the bottom. And here's 2 hours, 4 hours, 8 hours, 12 hours, 16 hours. Okay. So what do you do when you go to work? Do you zoom in the door and run to your cubicle and boot up your computer and start working? Or do you go get a cup of coffee and talk to people and say, what has happened to our stock today? And you go up and you go to lunch and you have bathroom breaks and stuff. You tend to go up, and about 80% of the time you're at work, you're actually working. The rest of the time you have breaks. You're talking to people that aren't, maybe it's not one of the important meetings or one of the meetings where everybody talks. And so you're about 80% of the time you're getting work done. Now, at 8 hours, you're at work. What happens after 8 hours if you're a non-exempt employee? Non-exempt, you get paid overtime. But if you're an exempt employee and you're in the rarefied, 50,000 plus range, and you can work 100 hours a week and they still pay you the same, then what happens there is people get paid overtime, their efficiency tends to drop. After 12 hours, you've been at work 12 hours that day. This is where you become a paperweight. If you're a coder, after 12 hours at work, then you have so many errors in your work in the past 8 hour range that the next day is cleaning up all your bugs and defects. So the thing to remember is you only get 80% work when you're at work. So when you're actually looking at efficiency, when you're looking at doing one of these calculations of how many you do, I tend to pull up the NASA Learning Curve Calculator online. Okay? And if something takes 10 minutes the first time, a good estimate when you're doing something is to divide it by 80%. So what's that going to be? What is it? 12.5? Is that right? 1 point, whatever. All right. So I divide this out, and that's what you do to find the number of minutes for your first time. And then with the NASA Learning Curve Calculator, I tend to use the Crawford method. And you can use that formula that we showed you earlier. And you use Crawford and a NASA Learning Curve Calculator, and you put the first time in, whether it's 10 minutes or whatever, and you put in the learning curve, 90%. Now, if I put in 40%, that's unrealistic. The second time I do it, I do it in 4 minutes. And the fourth time I do it in 2 minutes, it's not going to be realistic. So typically it's a 90% or a 95% learning curve. You save some 5 to 10% of the time when you do it the second time. And the fourth time you save about that much. But if you decide you're going to do it and you're going to make 10,000 of these things, the first time was 10 minutes and you had a 90% learning curve, it'll give you a cumulative time down here, cumulative time, and that cumulative time will take so much. Now, what if I'm going to do just 5,000 of them? I won't get as much. I can do it in a lot less time, but I'd have 2 people working on it. If I have 4 people working on it, I'm making 10,000. Then each person is making 2,500. Now remember, it's probably a good idea to start out and take your first time and divide by 0.8, because if you're working on something and making 2,500 of them, you're not going to get 100% of your time. You're going to get about 80% of your time you're actually working. And that's how you have to figure these things. And when you're doing a calculation, remember that after 12 hours, you're a paperweight. So let's look at this. Here's one. And you can see, if you look log scale, this is just a simple progression of doing something. Consider always that you don't get 100% of your time when you're working on multiple iterations.